Hey everybody, I wanted to talk today about the most recent sea level curve. And this is derived from corals, which are amazing sea level recorders. So the critical piece here is that corals grow in subtropical waters within about 5 meters of the sea level, because that's where the light, they need light for symbiotic algae that grow within their skeletons. So they have to grow in the photic zone. They need a lot of light. So they're growing in very shallow waters. And if you look at a place where you've got coral, such as Barbados, which has been instrumental in developing this curve, and you look at corals that are cored off the shelf in Barbados, so in somewhat deeper water, you find that you have corals that previously grew in waters that are around 120 meters below the current sea level. And you can take these cores, and you know their elevation because you core them. And so you have a core at about 120 meters below current sea level, and you can date the coral using carbon-14, which is a very precise means of acquiring an absolute age. What you find is that that coral growing at 120 meters below current sea level gives you ages at around 18,000 years ago, which is the height of the last glacial maximum. And what you find is that as you get shallower and shallower in places like Barbados or Tahiti or Bermuda, places like that, what happens is you get shallower and shallower, the corals get younger and younger. So that when you go to Barbados and you look at cores that are taken about 20 meters below the current sea level, you'll find ages of about 9,000 years. And by doing this, by taking lots and lots and lots of samples off the flanks of these coral growing locations like Jamaica and some places in Australia, you develop a curve like this. So the youngest corals are growing today. They're giving you ages of 0, and they're at current sea level. And what you find is this curve, basically this curve. And this curve is associated with melting during the transition from the last glacial maximum through to the current day. And what you see is slow melting and slow sea level rise. Then all of a sudden you get much more rapid melting. You get this meltwater spike where you got very rapid melting, and then it slows down a little bit, speeds up a little bit, slows down again in an event called the Younger Dryas, and then it speeds up again. And then at about 7,000 years, things start flattening out as most of the melting has occurred. This is a really precise sea level curve, and when you compare this with sea level curves that have been developed for the Cretaceous millions of years ago, those sea level curves are far less precise. What we've got here is the combination of carbon dating and some other isotopic dating, which gives you really precise age control, and then obviously the ability to determine elevation from current sea level in very close-in locations, close to sea level. You can do this extremely precisely. And you see actually very low amount of scatter in this curve, and a very well-established melting pulse associated with deglaciation. Anyway, so that is just a quick primer on how corals can be used to provide really precise sea level measurements.